Charles from GMAT Ninja here again. I didn't bother erasing the board from the last one. Hour number 5 of our nonstop 24-hour GMAT crash course marathon. This one's going to be on percents and interest rates. Another quant block. We're going to start this off exactly the same way as we did the last couple. So I'm going to give you a quiz, 5 questions, give you 10 minutes. All right. Have fun with these, everybody. I'll see you in about 10 minutes. All right. Welcome back, everybody. So again, a little bit of an experiment. So this is, I think, the second hour we're doing a quant lesson, starting with a quiz. So I'm still kind of figuring out the flow of these lessons when I see your data, like literally just showing up in the sheet as we go right now. And I'm watching like the percentages changing. So a little bit of improvisation here. It's interesting. Like I'm kind of seeing people in the chat go, oh, these are easy. These are easy. Our average percentage right is not much higher than half overall. So we're at 60, 65% maybe total. So a lot of struggles on these questions, which is interesting. Now, again, kind of the theme today is what you're really doing wrong on these different question types. I'm not going to walk you through too much of the basics. We only have an hour per topic. But what I'm interested in is what are the kinds of things that you walk into that are a problem. So I know you guys won't be very happy with me if I skip all these questions we just went through. So I'm going to bash through these 5 quickly. I'm going to focus more on the ones that you struggled with, and then we've got some harder ones as we keep going. First one here, we got a guy named Carol. Good Ukrainian name. $5,000. 4% annual interest. 1 year. Compounded semi-annually. Part of what I'm after here, part of why I put this into the quiz was I was kind of interested to see, so what exactly is it that you guys struggle on? Like the basics is a pretty straightforward question, right? Am I seeing errors on it? Actually, I am. So I'm seeing about a 30 of you guys struggle on it, maybe a quarter, something like that. The numbers keep moving on me, which is great. Yeah, actually, more than a 30 of you missed this, which is kind of fascinating. Simple interest just means you're getting the same dollar amount every year. Compound interest, there's this temptation to kind of get super complicated with the formula. Hopefully I'll have time to do some harder ones with that in a minute, where the formula kind of breaks down on you. Compounded semi-annually, I think the mistake I'm seeing probably about a third of you make is that you look at this and go, well, okay, hey, that's 4% twice. So I take the $5,000 and I multiply by, let's say, a 1.04 and then 1.04 again. Because semi-annually, every 6 months, I compound it twice. This is not correct. 4% annual interest means 2% per 6 months. So I think that's error number 1 that I'm seeing from a good chunk of you guys. Error number 2 possibly is, so even if I change this to 1.02, I think a lot of what's going on here is that, well, this isn't very helpful. I don't really want to multiply out. I'm not going to do long multiplication here. Like this isn't any fun. This sucks, right? So what can we do instead? Again, a lot of the theme today, flexibility. My engineers sometimes get wrecked by this. The guys with better math skills fundamentally than I have, much more advanced math, right? Do math for a living. I guess I do too, sort of. They'll kind of look at this and just go like, okay, I'm going to crank through this. I'm going to do the multiplication. It's going to be great. And it's like, no. Take a breath. What's 2% of 5,000? Not very much. It's $100, right? So 1% would be 50. 2% would be, 1% would be 50. 2% would be 100. So I can say in that first 6 months, $100. Then what happens with that second 6 months? Well, 2% of that, so another $100 plus another $2 because you're earning interest on your interest. That's it. 202, we're out of there. Super quick. I made a mistake there. Sorry, my bad. 2%. What did I do wrong? 2% of 5,000. That's right. All right. This is what happens when I get sleepy. Hour number 6, ladies and gentlemen. So just be careful of that phrasing on the annually versus semi-annually. Before I say anything else, Stacy Blackman Consulting sponsoring this hour. Thank you so much. Again, one of the originals in the I would say Stacey Blackman, was one of the great pioneers in the admissions consulting industry, one of the originals, one of the best. You need help. You're not sure what score you need. You're not sure which test to take. You finally conquered this thing. Go call those guys. Fantastic friends of GMAT Club. Fantastic friends of Ukraine. All right, next question. Nemirov vodka salesman. That's Ukrainian vodka, ladies and gentlemen. Is paid a salary of $1,000. This was a pretty easy setup. Saw pretty good results on this. Salary of $1,000 per month. Earns a 12% commission on all of his sales. Pretty straightforward translation. This is just straight old algebra in the setup. We want to know what must the annual sales be for a total compensation of $33,600. So $1,000 a month, that's $12,000. That's the base salary, 12% commission. So 0.12, if you're super, super new to percents, direct translation, what does the word percent mean? And I realize it's basic for a lot of you, but I'm seeing enough struggles from some of the crowd in the quiz. Means out of 100. So if you're translating literally 12%, you can just say 12 out of 100. Times that commission, call it X, whatever you want. All you have to do is solve for X. That gives the annual sales. I'm not going to bother doing the math. That one's pretty straightforward. Number 3. We've got a merchant buys a crate of guavas. Here's where we get into the really fun stuff. And I saw quite a few struggles on this one too. And I think those numbers are actually getting worse. So we had a lot of struggles there. About 40% missed it. Okay, so we've got the situation where we've got these successive percent changes. This is arguably kind of the most core foundational concept in the way the GMAT goes about percents, is fractions are your friend. This is one of the things I saw quite a bit in the chat where it's like, well, why is 16 2/3%? That's obnoxious. Yes, it's obnoxious on purpose. There's a lot of bad ways to do a question like this. So I'll lay out all the details of it. So it starts at X dollars. We're going to go up 100%. We're going to discount by 40%. And then we're going to discount again by 16 2/3%. And we want to know kind of that total profit or loss here. Here's the thing is that there's a lot of gimmicks out there for percent questions. I know a lot of people watching are super strong in quant and there's no issues here at all. But you can do a bunch of different things. You can pick numbers here. You can say, well, let me pretend it's $100. And then, okay, cool. Now I'm at 200. Now I'm 40% less than that. I'm at 160. No, that's not right. I'm tired. 120. Hour number 6. Nonstop, ladies and gentlemen. Please donate to our charities. At 120. Now what do I do with this, right? So am I going to take 16.666 and multiply it by whatever I've got here, 120? I mean, this stinks, right? As soon as you try to use decimals or pick numbers, some questions, it's great. Those are good tools. Fractions are your friend here. It makes this such an easy question. Because all I have to do is say if something goes up by 100%, what do I multiply by? I multiply by 2. I've got 2 times my original. Now, whatever that is, if it goes down by 40%, I multiply by 0.6. I prefer to use the fraction there, but if it helps, so a lot of you guys use a lot of Excel in your daily lives as pre-MBA types. Yeah, I put the 0.6 in, that's fine. I can translate it to a fraction later. That's 3/5 I'm multiplying it by. And then down by 16 2/3%, not unusual at all on the GMAT. Some of these percents that at a glance look exotic, this is a pretty simple fraction. This is a 1/6. So if something declines by a 1/6, we've got 5/6 left. So it goes down by a 6, I can multiply by 5/6. And that's it. Everything cancels out. Nothing happened. So the 5s cancel, the 6 cancels with the 2 and the 3. We're right back where we started at X. There is no gain or loss here at all. Did I make a mistake here somewhere, guys? Probably. I'm getting some comments in here, but I don't think so. 100%, discounts by 40%. That's right. That's right. Okay, I think we're good. Yeah, I've got people telling me I made a mistake, but I don't see it in there. Okay. Okay, I had it right. Thanks for scaring me, you guys. So this is one of the big keys to being efficient. So fighting that engineer's disease that I've been talking about kind of all through the day so far, that flexibility where it's really, really easy to go super orthodox and not kind of do that step 2. So I ask you to read twice, plot your path forward, find the best way forward, not just pick the first thing that comes to mind. First thing that comes to mind might be picking numbers. Maybe that's good, maybe it isn't. Depends on the question. Might be to multiply a bunch of decimals. Maybe that's good, maybe it isn't. Give yourself 20 seconds. See if you can find the best way. Fractions a lot of the time on these percents questions. Cleans it right up. All right. Next one, number 4. Again, about a third missed this, kind of to my surprise a little bit. People are looking at this and going, oh, that's super easy. And yet I'm managing to punk half you guys on it, or close to it, a third of them. Pleasantly plump pig breaks into a large grain silo that contains 900,000 pounds of corn. Pig eats 27 pounds of it. What are we really asking here? We're really asking 27 is what percent of 900,000? Now, a lot of ways to do this that are fine. My preference here, if they give me the chance, pretty much across the board on the GMAT, if they give me a chance to take a word problem and translate directly and go word for word, I'm taking the chance. I'm taking the opportunity because I'm going to get something that's super reliable, right? Every word here turns really neatly into a piece of algebra. 27. The word is just means equals. Makes me think of Bill Clinton for any Americans that remember that guy or anybody else remembers that guy. Depends on what the definition of is. Google it. It's hilarious. Is what percent? What's my variable? Call it X, whatever you want to call it. Percent out of 100. Of means multiply. If I say 1/2 of 60, what are you really doing? You're just multiplying, right? The number 30 pops in your head right away as soon as you see this. But what are you doing? Of means multiply mathematically. And now all we have to do is just clean up the math and we're out of here. So cross off 2 zeros there at 9,000. X is equal to 27 over 9,000. I was going to say, stop me if I do something silly, but you guys have been leading me astray and telling me I made errors when I didn't. And I'm going to make lots of errors, but all right, over 1,000. So it is that. Well, that's here's where you can get yourself into some trouble. This is your answer, guys. Slap a percent sign on it and you're done. Your answer is 3/1000%. And that is it. So answer there is D. So again, punchline here, be literal. They give you the chance, be literal here. And every word in a straight percents translation is going to turn to a nice, pretty little symbol. Laughing at the comment that I'm going to keep reminding you that I was right and you were wrong. Not true, because it is just a matter of time before you guys catch me making mistakes over and over and over again. Last one. Last week, Buñuel earned, I'll write all this out, earned 150% more than Chuck. Buñuel earned 50% as much as Doug. Doug earned 600. And my question is, I want to know what's the sum of all of them. This one was a bloodbath, I think. I think we got about maybe 40% correct. Not even. So absolute bloodbath here, which is great. Again, pretty common question type. Here's the thing. Of multiply, right? So if I say 50% of X, well, that's 1/2 times X. That's what we have going on here. So Buñuel earned 50% as much as Doug. We can take that and go B equals 1/2 D. Great. Super straightforward. What about this? The temptation is to say B equals, well, 150%. I could call that 3/5. 3/5 C. Probably 2/3 C did this. And that is not the case. 150% more. If I had said 100% more, I might have said, wait, I'm doubling, right? 150% more, I'm more than doubling. I'm not multiplying by 3.5 or 1.5 by 3 halves. I'm multiplying by 1 plus that. I'm multiplying by 5 halves. So in that previous question where we had, or a couple questions ago, where we had the sort of, we had an item, it went up by 100%, it went down by 40%, went down again by 16 2/3%. The concept here is these multipliers, right? So I could take this as a whole bunch of individual addition problems and say, I'm going to calculate 100%, add it back on, calculate 40%, add it back on, calculate this thing, add it back on. 6 steps, a lot of chances to make errors. Or I could think of it as, hey, I'm multiplying each time. A percent change is multiplication. Once you start thinking in terms of those multipliers, A whole lot of percent questions get much, much easier. And even if you're getting them right, which again, what I'm seeing out of the live crowd is the vocal people nailing it. Quietly, a lot of you guys are struggling. I don't think you're executing on this cleanly, most of you guys. So think of it as multipliers. Order doesn't matter. Think of the fractions. It's going to give you the most efficient solution path. And even if you are nailing these, if you get better at this, you'll be more efficient, save time for other things that are harder for you. Up by 100% multiplied by 2, up by 150% multiplied by 2.5. So this should be 5 halves C. And now from here, it's just plug and play. And this is where I'm very likely to make an error. So punch in the 600 for Doug here. Sarman, Buñuel, 300. What's going on here? So C is equal to 2/5 B. And we can punch that 300 back in. C equals 2 times 300 over 5. I believe that's 120. So 120 plus 300 plus 600 gives you 1,020. And that gives you answer choice A. All right. So foundations of percents, foundations of good hygiene. As always, with everything, you guys are going to get tired of hearing me say this. If you decide to watch the whole 24-hour marathon, read twice at the beginning, plot your path forward, get that flexibility in there. I want that voice in your head saying, find the best way, find the best way. Don't just choose the first way. And then think about multipliers. If you've got a percent change, your most efficient path is those multipliers. Fractions are your friends here. All right, we're going to up the difficulty level a little bit. I got great options here. I think I'm going with this one. Let's do a little bit of data sufficiency out of the gate, and then we'll swing back to some more foundational stuff. All right, coming back, seeing some disagreement here, which is fantastic. It means we picked a good hard question. What we were talking about earlier, it's how do you take a percentage and translate it? So yes, there's going to be some where the intuition really helps, but if they give you the chance to translate nice and straight, take it. Great example of it. So somebody takes a boombox CD, that's a Ukrainian band, by the way, buys it for X dollars, resells it for Y dollars. So profit is what percentage of the purchase price. And I can take this nice clean equation. Profit equals what percent? I can call it X over 100 of always means multiplication times the purchase price. Well, the purchase price was X. So let me call this something other than X, I guess. Let's say, I'll just say what? Why not use a word there? Of X. Well, what's profit? That's just the sale price, revenue minus cost, right? There's your revenue, there's your cost. So I can say Y minus X equals. And I'm being a little cheeky here with the what there. But if it helps you to be intuitive, go for it. There's no harm in this. This actually used to be one of my habits on word problems for a long time, was if I pick a variable that's not intuitive to me, I really risk screwing myself over, right? Where it's like, well, I made it Z, and then it's like, oh, what was Z? And we've already got X and a Y here. So it's like, you can leave it like that. You can call it Z if you want. You can call it A. You can call it Vladimir, whatever you want. My point is that this is what you're solving for. And it's going to kind of disappear from the picture in a second anyway. Get this out of my way. So if I'm trying to solve for this thing, I'm just going to rearrange a little bit, multiply by 100 over X, take this. So I've got that what, the thing I'm after. That's the thing I want. So it's Y minus X times 100 over X. And I could stop there if I wanted to, that'd be fine. But again, push the question on data sufficiency. How can you rewrite this? What can you do with this to make it more intuitive, give you a better shot at seeing something useful in the answer choices? I'm going to keep running with it. Now, the 100 doesn't matter. It's data sufficiency. I don't care about the 100. It's not going to change whether I know what this value is. So I'm going to get rid of the 100, rewrite it. This is what I want, is this thing. So here's my reformulated question. Y minus X over X is equal to what? And look, I can keep going. It's a fraction. I can split it up. I can say that this is Y minus X over X is equal to what? Well, that's just a 1. Data sufficiency, no mystery there. Know exactly what that is. This is all I need. All I need here is Y over X. That's it. Now, our intuition is again, maybe not everybody, but for a lot of us, kind of shot here, right? It's like, wait. How did I get to Y over X here being the thing? And it's really, really hard to look at the question and go, oh yeah, I just need y over x. You're probably not going to get there unless you're a real freak of nature. If you are, kudos. But if you're really just being nice and literal and systematic and you keep your algebra clean, and we get to this, and that's exactly what statement 1 says, basically. 5x, 5y equals 6x. Yeah, divide by x, we got it. Y over x is 6 over 5. A is sufficient. Statement 2, y minus x is equal to 0.2. That sounds good, right? I mean, it looks like that's the profit, but doesn't mean anything to me here. That's what I want. So our answer is A. Okay, how much time do we have? We got time for 3 or 4 more. Next one I'm going to give you is, I won't preface it too much. Have fun, guys. Nothing technical here, right? I mean, this is pretty straightforward. It's gentle numbers, 40%, 20%. Hey, what are we really talking about? And this is classic GMAT. It's really easy to get in that mindset of like, oh, more math, more math, more math. And it's like, nope, keep your head on. Make sure you keep your intuition engaged. We like to say, use your human brain. Really good case of it. So really easy for me to say, like, all right, in August, all right, we got Mr. Zelinsky is 40% of the total earnings of the household. So I can say that, like, we'll say Z, meaning Mr. Zelinsky, is equal to 0.4 of the total. Okay, so then if he goes down by 20%, the temptation here is to say, well, now this guy is 0.8, down 20%, we can multiply by 0.8 times the 0.4t, and we get 0.3t, which means 32%. And that would be answer choice C. 10 points if you spot my error. This looks right. It looks fantastic. Very often the case. Like, how does the GMAT get you off of 9th and 10th grade math, right? It gives you things that look right but aren't, and things that look wrong that are right. Verbal, ton of that, right? When we get to sentence correction today, you'll see tons of that where it's like, yeah, right answers that sound awful, correct answers that, but I'm being redundant. Right answers that sound terrible, wrong answers that sound good. Classic thing, right? There's another case of it. This just looks right. It just does. Here's the thing. If Mr. Zelinsky's income went down, what happened to the whole family's income? The rest of the family's income stayed the same. His went down. That means the whole family's went down. So you can handle it algebraically. You can pick numbers. It doesn't really matter to me in this case what you do. If we want to take it at kind of a really, really kind of super kind of reductionist level where we say, I want to pick numbers. I'm not a big fan of picking numbers in general. You could here if it helps you and say, well, the total's 100 and Mr. Zelinsky's 40. It's problem solving. I'm okay with picking numbers here. So in September, what happens? Well, he loses 20%. So 0.8 times that 40. He is indeed down to 32, but that means that he lost 8. So the family total is 92. You can do it algebraically, you can do it with variables, doesn't really matter. I don't think either way is particularly difficult here. My point is, it's really, really easy to fall asleep at the switch and not recognize that the entire family's income is changing when Mr. Zelinsky's goes down. So now what's his percentage? 32 over 92. We know that this is going to be bigger than 32 by how much. You don't have that many answer choices here. I mean, you could probably just get away with saying, here's C, here's D, here's E. This is nowhere near 40%, pretty close to 35%, it's 34% and change. Definitely closer to 35, whether you decide to do the math all the way out or not. You could reduce here if you wanted to. Does that help? I think so. I mean, I can kind of look at this and go, it's a little bit more than a third. 8 over 24 would be a third. This is a little bit more. I'm pretty confident right there. I don't even need to do the long division now. So your answer is D. I got most D on that one. And again, this is, I wrote this version, but very, very close to what you see on the actual test in a couple spots. All right. Do we have time for 2 more? Let's go with this one. Let me give you a really hard interest rate problem next. Okay. Here's the deal. So anybody with engineer's disease, which I've been talking about a lot today, And what I mean by that, no disrespect to engineers, because most of you guys know so much more math than I do, and I respect it a ton. It's kind of that drive to kind of do a bunch of algebra here. And that's exactly what this question is kind of driving at in a way is, well, yeah, okay, I know my formula for compound interest. So if I got $2,000 1 year compounded annually, 1 plus P over 100, and it's only 1 year, so I don't need to square it or anything. Like that's it, right? Like that's it. Cool. And then I've got the semi-annually. So it's like, okay, there are some basic things that you could do wrong here. So one of the things we talked about, I think in the very first question, is not recognizing what happens to that interest rate. So you might say, well, this is $2,000 times 1 plus P over 100 squared because we're compounding twice, right? We earn that interest twice in a year, but you're not getting that full P%. What you're getting isn't P% every 6 months. You're getting P over 2% every 6 months. So that's fine. Easy enough to fix that. This is an ugly way to write it, but just for the sake of illustration, that's really what you're doing. That's funny. So somebody put in the chat, thank you, Daniel. Feel free to disrespect engineers. No, I respect you guys a ton. I love it. Taught a ton of engineers, and this is the kind of question that tends to get them. So I'm going to write that as P over 200. So again, the concept here is if it's compounding twice a year, interest rate cuts in half since the period cuts in half. Great. And so now I just subtract and I'm great. I take this and I subtract this thing. And what the heck are we doing? So 2,000 times 1 plus P over 100. And I guess I can factor out the 2,000 and I get 1 plus P over 200 squared minus 1 plus P over 100. And I'm lost now, and I've got brackets inside brackets, and I guess the ones are going to go away, and you can do it. You can do it, right? Like it's not to say this is impossible, but when I talk about kind of that step one, step two, read the question twice, make sure you're not missing something, plot your path forward. I should recognize pretty quickly, way before getting to this stage, there's got to be a better way. Every GMAT question, there is a way to do it in under 2 minutes. We're not going to find it every time. I don't find it every time, not even close, especially not when I've been up for 24 hours. But you should recognize you're in trouble here. Think about where you're headed. I'm going to have these complex formulas and then subtract them out. Can you? Probably. Sure. I'm not doing this. I'm too lazy. Lazy American. Bad math training. Lazy. Not doing it. Instead, let's think conceptually. Why do you want... Think about this question, and I think almost any time you encounter an interest rate problem, unless it's super straightforward, what's going on? Like, what if you're the one investing here? What would you want? Do you want to compound annually or semi-annually? What's better for you as an investor, and why? Simple interest versus compound. Obviously, you like compound interest more than simple because you're earning interest on your interest. Same interest rate. I like compounding more often, right? If I can compound monthly, daily. Great. That's the way credit cards work in some places still. They compound your interest charges daily. That stinks for you. Okay. So I'm happier here. Why? I earn interest on my interest more frequently. What does that mean exactly? I earned some interest in the first half. The only difference between these two, first 6 months of the year identical, right? Second 6 months, this guy over here earning semi-annually is earning interest on the interest in the first 6 months. So conceptually, what's the difference? Earn interest, specifically P over 2% interest on the first 6 months. Once you recognize that, you are out of here. This is it. And exactly, this is the power of compounding. See people putting that in the chat. It's exactly it. This is the power of compounding. Once you recognize that at a conceptual level, there's very, very little math to this problem, and it all cleans up. Very typical GMAT. Okay, so what's my interest in the first 6 months? Well, it's P over 200 times 2,000. That's it. So 10P. And again, that's first 6 months interest. Well, how much do I earn on that? I earn P over 2% again. So P over 2%, P over 200, because that percent is over 100, times P over 200 My handwriting is falling apart on me already. And we got p squared over 20. That's it. Classic, classic, classic. Not to say that you're going to see a lot of this exact construction of the question. That's not what I mean at all. It's classic GMAT. How do they make it quantitative reasoning and not math, which they're so proud of saying when you talk to internal people there. It's that if you try to get too mathy with a lot of their problems, you can get punked. You get into a quagmire of really, really messy algebra that you just don't need. And there's a conceptual way out. That's their thing. All right, we're going to run through one more quickly. Going to go through this super, super quickly because we're out of time. Really, the issue here is it's being literal. It's making those translations really cleanly. Not seeing a whole, first few people got it right, but then a lot of people didn't answer. So I think there were a lot of struggles on this. I'm going to start with this part first. Wholesale price is $33.60. Wants to make a 25% markup on that. That's pretty straightforward, right? We can just go that she wants the sale price to be I'm starting to lose it. 5/4 times 33.60. And we can cancel very nice, neat multiple of 4 here. So $8.40, I believe. Multiply that times 5. I think you get $42. And if she wants to offer a 25% discount on the marked price, what we're saying is that she wants to take that marked price, I'll call it M, multiply it by 3/4. Again, 25% discount, all about those multipliers. And that's going to give you the actual sale price, which is $42. Shake and bake, we got it. 4/3, if I'm not mistaken, that's 56. So again, intimidating to get through the text. Saw some people kind of complaining. It's like, whoa, my brain's hurting reading it. Typical GMAT. You're going to see that over and over and over. It's not to say that they're deliberately larding it with too many words. I don't mean to make it sound like that. But they're giving you the opportunity to say, if I break it down, if I'm nice and systematic with it, I've got one piece here. I've got the wholesale price. I'm going to take it one step at a time. 25% profit. Clean little multiplier there. 25% discount on the mark price. Clean little multiplier there. Not so bad. Take a breath, break it down. You're going to be okay. Later on, a couple hours from now, we're going to do a whole segment on scary GMAT math problems with unfamiliar symbols, tons and tons and tons of words, all about trying to overcome that intimidation. That's our next quant block coming up in about 2 hours. This is the end of hour number 6. I have survived 1/4 of our GMAT Club crash course 24-hour marathon for Ukraine. More verbal coming at you in a second.